Okay, so very good afternoon to one and all present here in this call. Already we have got our honorable speaker here in this call. He has already joined. Dr. Somenath Chakraborty, Assistant Professor, Computer Science and Information Systems, West Virginia University, Institute of Technology, USA. Thank you, sir, for joining the session. Welcome you from the portals of Hooghly Engineering and Technology College. Today it is day 3 of the 1-week faculty development program, Industry 6.0, Navigating the Ethical Frontier of Artificial Intelligence and Data Science. Thank you participants for joining in good number. As we can see, more participants are joining in, but we have to start as the session is scheduled from 3 p.m. onwards, so we have to start here. Let me introduce today's speaker. He has got a vast experience in varied fields, but to be very precise, Dr. Somenath Chakraborty is an assistant professor at the West Virginia University Institute of Technology, Beckley, West Virginia, United States of America. He has experience of 11 years at the post of lecturer, assistant professor, and principal, former principal of Harirampur Government ITI, Nanoor Government ITI, and Itahar Government ITI. Strong research expertise in the field of artificial intelligence, medical image and data processing, machine learning, pattern recognition, and digital image processing. He has published many research journals, conference papers, book chapters, etc. He is an IEEE senior member, IEEE Computer Society member, IEEE Computational Intelligence Society member, as well as IEEE Young Professional member. Dr. Somenath Chakraborty today is our honorable speaker. I welcome him once again. I, Dr. Shubham Ganguly, on behalf of Hooghly Engineering and Technology College, as well as the IQAC of our college. And also, this FDP, as you know, is a joint effort of the IQAC, IIC, and EDC of the same college. So here we start. Today's speaker, Dr. Somenath Chakraborty. Over to you, sir.
Thank you so much. So I am sharing the slide. Hopefully it could be available at your end. So everybody able to see my slide in full screen? Could you see my slide in full screen?
Yes, that is visible.
Okay, thank you.
Yes, sir.
Today's talk is Industry 6.0, Navigating the Ethical Frontier of Artificial Intelligence and Data Science. The roadmap, I will start with the quote from Albert Einstein, where Albert Einstein says, we cannot solve problem by using the same kind of thinking we used when we created them. So we need diversification of thinking to create any new things. And that's the basic thought about that. So in today's talk, I will give you a little bit brief about me. Then I will discuss a very little bit descriptions about what is Industry 6.0. Then AI, how it is evolved over a period of time, what are its aspects, the different fields associated with it, and why we call a new field called data science, and what are the shortcomings of AI, that is explainable AI, a little bit brief about that. And then I will discuss about the ethical aspect of implementing all these technologies. And I will highly expect that if I have something which is not clear to you at your end, or you have some questions, so then they can shoot out those questions to me, and I will try my best to answer those. So is it sound good? So let's start with my introductions. So I am currently assistant professor at West Virginia University Institute of Technology, Beckley, West Virginia, USA. This is my personal website. You can look into that. You can also look into our university and other websites where I am available. My digital footprints are available. Before this current position, I was a graduate teaching assistant in the School of Computing Science and Computer Engineering at the University of Southern Mississippi, USA, from August 2022, 20 to July 22. Then I joined my current positions. While working as a graduate research assistant and graduate teaching assistant in the School of Computing Science and Computer Engineering at the University of Southern Mississippi, I also completed my PhD in computer science and engineering. Before coming to the United States, I was working in India for many years, more than 10 years. And I work as a principal at Harirampur Government Industrial Training Institute, Itahar Government Industrial Training Institute, and Nanoor Government Industrial Training Institute as a principal, and also the founding members and all the inaugurating part. I was involved in all those AICD and Government of Education related development papers, submitting those inspections. I was in charge on those as well. Um, Prior to that, I was working as a lecturer, senior lecturer, and assistant professor in Department of Computer Science and Engineering and Information Technology at Sharaj Mohan Institute of Technology, which is under the Techno India Group, which is a renowned educational institute in Eastern India from 25th August 2007 to 15th May 2016. After coming to US, and when I was switched my position from research assistant to teaching assistant, I uh, understand that it is better to have more qualification and more understanding of the teaching things. So I completed the Council on Undergraduate Research and the American Council on Education, that is ACE, which actually the governing body of all educational institutions in USA. And they provide different kind of certifications by which instructor actually trained how to deliver their lectures. So I am certified both CUR and ACE, both for teaching and research purpose. While pursuing my PhD, I was elected 2 times as a president of Graduate Student Association for Arts and Sciences, and I served the role from April 2021 to May 2022. I was eco ambassador as well, promoting the use of biodegradable instrument, not use plastic, saving the environment, those kind of activities. That is called eco ambassador program. How we can make our environment and art sustainable. That is the goal. So it is actually from Office of Sustainability. That role I served from August 2020 to July 2022 at the University of Southern Mississippi, USA. Currently, I'm a senior IEEE member, IEEE Computer Society member, ACM professional member, and there is a ACM chapter you may be aware of. So I am the faculty supervisor of ACM chapter at WTech as well. I'm a member of IEEE Young Professionals Faculty Assembly committee member at WTech, which is actually the faculty association of WTech. I'm author and reviewer of many IEEE, Spinger, Wheatley, MDPI journals, international conference, and I give a keynote talk and lecture as well. And I have some grant. One of them is Open Educational Grant. What is Open Educational Grant? In Open Educational Grant, it is an initiative of National Science Foundation and the West Virginia Educational Department to create resources by eminent professor, and that can be freely used by any student in the US. So those open resources are shareable and free to all. That is called open educational resources. And I personally write the different proposal, and I was awarded by the NSF and West Virginia Higher Education Policy Commission 2 times as a open educational grant awardee faculty. There are other some grant where I am the PI and co-PI. I'm also editor of many journals, technical and organization committee member of many international conferences, and I try to engage with my peer colleagues where I can be part of different conference and have good experience. So now I will start with the industry 6.0, what is actually it is and uh, what is in current positions of it. So industry is basically whatever scientific and educational things. Education is come under in industry purpose, but what we understand industry is everything that has an applied field, and we can make some kind of a um, um, some kind of a facility for people by which civilization actually proceed. So to prosper the civilization, industry is very much essential, and we need to develop over a period of a time, and there are a lot of new development happening all the period of time in this process. So when we are discussing about Industry 6.0, it's not just about automating factories by taking a lot of measures where a lot of different technology we are using, but rather transforming the entire industry through the integration of advanced technologies, enabling smarter decision making. So it's not only the field by which we actually transform different goods to a productable good, but also decision making, how we can make effective and very prompt and fast decisions by which a higher productivity can be produced. That is the objective of the industry as well, and unprecedented level of customizations. So this customization is very vital in this case. So suppose you are asking for a good to purchase, or you are a particular customer is interested to buy some product, but whatever product they are receiving is not matching all the different parameters of their choice. So suppose a particular person is, I'm giving you a very simple example on that. Suppose a particular person looking for a pen to write. So there are a lot of parameter he will be need to be satisfied by that, but whatever available product available, that cannot give them the fullest level of satisfactions. So the customizations enable them who are the end buyer or the customer to customize according to their choice and needs, and that is actually automated through different sort of integrated systems, user interface, stuff like that, and that is actually a new kind of a development in terms of a industry 6.0. Basically, Industry 6.0 represent the next phase of industrializations, which is focused on creating fully integrated. And what does this integration mean? This integration means that whatever operation, it could be manufacturing, it could be decision making, it could be product improvement, it could be logistic handling. Every micro operations are integrated fully in an automated fashions, and the intelligent manufacturing system that can operate with minimal human interventions. So what is this minimal human interventions? So that we can ensure many processes do not have any human error incurred on that. Only a very few smart people are interacting with these automated systems, and they can enhance the processing. In India and in rapidly growing industry through all over the world, we are actually expanding this Industry 6.0, where strong technological infrastructure and abundant talent pool. I obviously like to mention, if you look into the global talent pool in automated industry, IT industry, computer science industry, India play a vital role, and a lot of IT professionals actually play a key role here in US as well. So there is the audience, mostly I know many students are listening to today's talk. I will highly inspire them that there is a global opportunity all over the world. If you can be part of this technology, if you learn this technology, you will be the key player who are using this, who are developing this and contributing actively in this industry 6.0. Uh, and there is a global opportunity to become a major player in this industry 6.0 ecosystems. So what are the new technology we need to learn, and we need to make those technology, use those technology, make easily accessible interfaces by which anyone who is not much aware of the technology, but they can also use this Industry 6.0 products or integrations. So this technology include mostly artificial intelligence, and I will give you the overview of artificial intelligence, because artificial intelligence is a big umbrella, and lot of technology is actually part of artificial intelligence. And therefore, a derived part is data science. I will give you a little bit brief on that as well. There is a cloud computing, as we know, like our data are emerging and exponentially growing. To support seamless data connectivity through those huge databases, we need cloud computing, which can enable any kind of a devices, even IoT devices, that can be directly connected with the internet, directly can be controlled. That control can be performed from the remote end, so that we call it remote control, and also huge amount of storage. So all these aspects will be handled by the cloud computing itself. And we are also need to have green energy. That is the big part, because we need to transform ourselves from creating a lot of pollution to a environment where we can use green energy. We are emphasizing on using low amount of electricity, and the electricity and the power should come from a renewable source or green source. So this green energy mostly emphasizing on reducing the electricity consumption, power consumptions, and also the way we actually acquire those powers. That should be renewable or green sources. And there is a new technology emerging rapidly, and that can have potential to change all kind of current industry right now. That is the quantum computing. A lot of development already happening, and there is a lot of prospect for future development. And 3D printing, 3D printing is one of the way by which we are not making small product nowadays. You may have heard of like the whole house is built on a 3D printing basis, and that is actually commercially distributed on a small and highly scalable manner. Uh, so I will discuss about those related technologies a little bit, and there are other technology also obviously part of Industry 6.0. Uh, so I will give you a very brief introduction to AI. So I start with this. Alan Turing gave you a picture. As we all know, Alan Turing, who is also regarded as the father of computer science, who is a renowned mathematician, and also the cybersecurity, that the most popular field of today, is actually invented, and we also decode the German code, and very famous personnel who actually regarded as the father of computer science. So he developed the Turing test, which actually, if we can build a machine and that can a human cannot distinguish between a human and machine and can fool that human, then we call that particular machine a tuning test. And if we can build that efficient machine, though there are argument whether we can build the fully 100% tuning test, any our systems can develop that or not. But basically, the common concept is if we cannot distinguish whatever operation, interaction, or anything that is happening by a machine is indistinguishable by a human, then the machine is intelligent enough and pass the tuning test. So there are other definitions of AI. I just like to mention some of them from famous people. So Alan Turing says actions that are indistinguishable from a human, that is an intelligence, AI, artificial intelligence. So what about the concept that is given by David Ma? So he says AI is the study of complex information processing problem that often have their roots in some aspect of biological information processing. The goal of the subject is to identify soluble and interesting information processing problem and solve them. So from this code, we easily understand they are emphasizing on biological information processing, where from our cognition system, our brain actually built, and how those information that a human take to make a smart decision in any kind of environment, that is actually the central part of understanding what is intelligent decisions and how we make them. So we are actually developing those systems which can make information processing problem in that scale and can solve them intelligently. That is actually a very renowned, distinct, very meaningful code. That's why I include it. And another Australian roboticist, Rodney Brooks, what he says the intelligent connection of perception to actions. So here he emphasizes on the perception, how we see things through our senses. So human already has natural sensors by which we actually perceive our environment, understand whatever we are actually perceives. So those perceptions, how we transform it from perception to action, that is actually the central part of this code. To my audience, I will highly encourage to read this paper that is currently available from 2009 onwards on Springer, that is LNM Tuning Computer Machinery Intelligence. It's parsing in the tuning test. There is more interesting part which I cannot cover. You can read those. So today, the hot topic is ChatGPT. ChatGPT is a very interesting thing in today's world. So, what if I ask ChatGPT what is AI is? So, very interesting answer I got from ChatGPT. That is the auto. I will talk about its technology and background a little bit. But first, let's see how ChatGPT answer what is AI, what is artificial intelligence. So ChatGPT says artificial intelligence refer to the simulations of human intelligence in machines that are programmed to think and learn like humans. Very accurately mentioned. So the simulation signifies that the way a machine works now and mimicking the human intelligence through the machine. So we need to create different machine, and that should simulate all the actions we perceive. We perceive general action like how we walk, how we'll talk, how we'll see things, stuff like that. So all human activities where intelligence is required, that need to be mimicking by those machines. That is the simulations. So it is a broad field of study and research in comprising various technologies and approaches. So AI systems are designed to perform tasks that typically require human intelligence, such as speech recognitions, the way one language can be transferred to another language seamlessly without knowing that language, and that speech can be recognized by the system, translated from one language to another language, stuff like that. Decision making, problem solving, visual perception, the way we perceive through our eyes and through machine eyes. As you know, for different space research, they use very sophisticated cameras where they use different sort of radars and other kind of visual perceptions, which by which they can see far beyond things. Language understanding, as I mentioned, different sort of how there is a field called NLP, natural language processing, by which this language understanding and translation actually happen by the machines. These systems use algorithm. That is the central part. Any computational thing should be solved initially making an algorithm and then developing the system. We need huge amount of data and computational power to analyze and interpret information. What are the internal meaning with that? And then make predictions and generate response or actions. I teach artificial intelligence, and there are different books of different definition because there is no common definition of AI. But this definition I personally see is comprehensible and very integrated one. That's why I bring this slide to you. So what are the different types of AI? And ChatGPT easily able to distinguish those very efficiently as well. So they categorize as different types of AI. The first is narrow AI, also known as weak AI, and they mention narrow AI is designed to perform specific tasks within a limited domain. Example include voice assistant like Siri and Alexa, recommendation systems, and image recognition software. There are general AI, which is still many scientists argue we still not achieve that fully, but some sort of general AI where one sort of intelligence can be transferred to another sort of technologies, and we are in the process of creating those AI, also referred to as the strong AI or AGI. Most of the current development of artificial intelligence currently focuses on developing that technology. We still not actually developed that fully. That is called artificial general intelligence. General AI aim to process human level intelligence and beat humans in many levels as well. And the ability to understand and perform any intellectual tasks that a human can do. This level of AI is still largely hypothetical and has not been achieved yet, correctly mentioned by ChatGPT. And there is a field called machine learning. I will give you more understanding on that. Show how ChatGPT interpret. It says it is a subset of AI that focuses on developing algorithms and models that enable machine to learn from and make predictions and decisions based on data. Machine learning involves training models with labeled data and allowing them to improve their performance through experience. And there is a advanced field of machine learning that is called deep learning. A subset of machine learning, deep learning involves the use of artificial neural network with multiple layer deep neural networks to process and learn from vast amount of data. Deep learning has achieved remarkable success in areas such as image and speech recognitions and many other areas. So how this AI actually develop and have this current um, huge amount of success that everyone talking about AI. What is the path where from this technology actually evolve? So I will give you some notable groundbreaking event. Due to lack of time, I am only choosing a few moments in the history which are still very much relevant, very much active in today's world. Those groundbreaking event I will only discuss. So in 1763, Thomas Bayes, everyone who are using and developing AI, they knows how Bayes theorem still used today and what is the significance on that. But it was actually developed in 1763, where a framework for reasoning about the possibility of events using math to update the probability of a hypothesis as more information become available. So this also the groundbreaking event of how the machine learning actually come into existence. That is the central part, those Bayes theorems and those hypotheses, how when we are actually getting more and more informations and applied those to actually generate more refined decision making. So this, due to this work, Bayesian interface would become an important approach in machine learning and marks one of the earliest milestone on our artificial intelligence timeline. But as we all know, that time there is no concept of robotics or AI. Basically, the name robot actually came from a general play, artistic play, which is in 1921, and it is actually written by a writer, chess writer Carl Capek, who introduced the word robot in his play called RUR, Rosum Universal Robot. That is actually a play to watch, and the word robot comes from the word robota. The literal meaning is work or slave. In 1943, Warren S. McLeod and Walter Pitts published a paper called A Logical Calculus of the Ideas Imminent in Nervous Activity. So they discuss about what are those logical like interpretation, how those math actually we day-to-day activity in our brain, in our cognition system we use. So is the blueprint of mathematical biophysics, this influential paper in which they discuss network of idealized and simplified artificial neurons and how they might perform a simple logical function will become the inspiration for computer-based neural network and later deep learning. That is the uh, central part of any kind of AI systems, and their popular description as mimicking the brain. It is actually developed and published by those paper in 1943. But what happened due to lack of sophisticated machines, huge amount of memory processing, AI was not developing so rapidly at that point of time. So what happened in modern times, I will give you a very brief overview on that. So in 1950, as I mentioned, Turing test was proposed by Alan Turing. In 1956, the term artificial intelligence was coined for a summer conference at Dartmouth University, organized by a young computer scientist, John McCarthy. And John McCarthy first coined the term artificial intelligence. Before that, this term was not exist. In 1961, the first industrial robot, Unimate born, which replaced human work in the industrial assembly line, because that time most of the industry, even in European civilization, European industry, that time it is more on different kind of levers and many mechanical process that need to be performed in a assembly, industrial assembly, and this Unimate actually able to replace those human repetitive works. And this is a very popular robot that point of time. In 1966, Shaky, which is a very intelligent robots develop the first general purpose mobile robot, which has huge potential, and it's actually a groundbreaking things that able to save the whole world, but it is not popular enough until and unless there is a media coverage given to artificial intelligence. Because when media covers something, the general mass, the general public, which do not understand AI, which do not understand any computing thing, who do not understand any technology, but connect to day-to-day activity, they actually connected to the media, print, paper, visual media. Now we have a lot of media nowadays. And how those media coverage gain? So it is this media coverage actually gained by the innovative work by IBM, the most diversified computing company who developed the Deep Blue. It's actually a chess program. The robot can play chess, and they actually able to defeat in 1977 the genius chess champion Gary Kasparov, and that is actually a very groundbreaking event because from that point onwards, it was become so popular that people believe in AI, and they believe that AI systems can be revolutionized and have a huge potential to grow. Then onwards, actually the rapid innovations happen in this field. A lot of support in terms of financial support, and industry also play a lot of money to develop those systems. So in 1999, Sony launched a consumer pet dog robot called EBO that is also targeting for the general mass who can use and purchase that pet dog, and that can have the ability to have different sort of interactive systems that we are currently using by Siri, Alexa, or some other system that is very popular nowadays. In 2001, IBM Watson also win the popular TV show Jeopardy. That is actually a lot of questions they answer, and they efficiently answered those. It is also a groundbreaking event and a lot of popularity gained by AI systems. In 2017, Google's AlphaGo beat world Go champion Kizi. Go is a game which has more combination compared to chess. More intelligence is required uh, because more number of combinations of moves are there, and very popular in Asian countries, mostly China, Vietnam, Korea. But in 2007, Google's AlphaGo actually able to beat. Go still regarded as the one of the most complex board game mainly played in Asia. In 2018, Alibaba, the Chinese tech group, who actually a revolutionary um, um, company, they developed a language processing AI, outscored human intelligence as a Stanford reading and comprehension test. The Alibaba language processing actually is able to score 82.44 against 82.30 on a set of 100,000 questions. In 2011, 2021, Facebook developed SEER, a revolutionary self-supervised computer vision robot that can take decisions by its own. That is also a ground-breaking event. Now, nothing was as popular as ChatGPT nowadays, because everyone is actually just surprised by these new innovations. So what is this ChatGPT? As we all know, Sam Altman and others, they started this company called OpenAI. The goal is to create general artificial intelligence, and they come up with ChatGPT, a NLP application, natural language processing application, rather we call it LLM. So what is this ChatGPT and this ChatGPT 3.5? So ChatGPT is an artificial intelligence chatbot. Those who remember Alexa or other NLP system that has very limited interaction capabilities and decision making capabilities, but this actually revolutionized and it actually developed. The initial release was launched on November 2022. So this is, we call it natural language processing and large language model or search engine. We can perceive this technology is the integration of all these, and it is actually the foundational model they are more focusing on, so that the interaction can be happen on any topic. So it, the way it actually perceive those information and response accordingly is very diversified and mainly focuses on general purpose. So there are questions that would be much more difficult for a particular person to give answer on those diversified topic, but ChatGPT can generate answer on those. That's why you call it general purpose or foundational model. And due to their development, there are by inspired by the OpenAI, ChatGPT, many other big corporates, and they also try to develop this kind of a natural language processing or LLM model, which can give response. So I like to mention it is not only generating a answer for a question, but it could be applied in so many automated systems. By using these, so many automatic system can be generated. That is the potential of this kind of a general purpose foundational model. So Google come up with the BART. Google BART is Google's answer to ChatGPT. It is experimental AI conversational service that's powered by Google Lambda language model for dialogue applications. Microsoft also integrated automated NLP systems with their Bing chat. There are other alternative also exist, that is Jasper AI, Cloudage, ChatSonic, etc. And now many companies are also coming with their ChatGPT alternatives. So what is actually this the background technology of this GPT-3 or the ChatGPT? So this is the 3 or 3.5. It's showing the generation, especially you can call it version as well. So this is third generation generative pre-trained transformer. So what is like that and why transformer is used here? So this is actually neural network model, and transformer mostly used for NLP application, by which we understand different semantics of natural language words, and they can transform those different short natural language words. Suppose we take 1000 words and try to understand their semantics, and that can be transformed into generating similar kind of a wording or understanding those wording, and we call that neural network model as a transformer. Transformer is very widely used, mostly used in natural language processing, but nowadays visual transformer neural network model also come and gain a lot of success. And what is this generative pretend? So generative signifies with a short amount of database or the training data set, we can make up a new kind of a neural network model that can generate new things. So generative model itself is a revolutionary technology in AI. And this generative pre-trained transformer actually exists before, and OpenAI, they just use it and make it a very compact and very revolutionary foundation model using LLP, large language model. That's why it can able to generate huge amount of response and can be used for many other purposes. So this is actually the full form of GPT-3, third generation generative pre-trained transformer. That's the full form. But these are the integration of different technologies that is actually pre-exist. Developed by OpenAI, as I mentioned, it requires a small amount of input text to generate large volume of relevant and sophisticated machine-generated text. And whenever you ask a small question, a lot of lines is generated, and that is actually I show you how intelligence answer it can produce. GPT-3 processes takes input to perform a variety of natural language tasks. It uses both natural language generation and natural language processing to understand and generate natural human language text. That's why it has so much potential in it. So if we are looking into the generative AI revolutions, so what is the difference between AI and general AI? So general AI basically by which we can generate. There is a two-part. One, they take information and understand those information, and repetitively they review what are the mistakes done by the neural network, and when they actually get a perfect response, which is actually a very intelligent response, we call it that is a generative things. But I like to give you a very clear and basic understanding of the generative AI to my audience, that when you see a computer generated image or a generative AI system generate a new music, is it totally innovative? Is it totally not existence anywhere? That is actually not true. These generative AI systems also use a small amount of database wherefrom they actually learn. If you do not feed that database, it actually not able to produce the output. But the thing is that they can learn from those data set and able to produce something which is actually refined with so much perfections that we cannot distinguish whether any existence matches there. I give you a small brief example. Suppose we are creating human faces through a generative AI technology, and we come up with a face which is not existent, matching with 100% with any person. But is there completely true? It is not completely true. There is a matching of some percentage, maybe 0.3, 0.1, but it is actually matching with so many faces and integrations of those so many faces. Those 1%, 2%, 0.3% matches are existing. So it is actually generate those things from some small databases. The performance is we are taking as very small databases and can integrate, and the system can learn. So it also has this timeline. So I will like to mention Elisa, that is actually a chatbot. Many people may be using Elisa. Maybe it's a very intelligent systems that can give response, and mostly it is a medical interpretation. Very limited amount of intelligence is there, and but that generative AI we actually know more about when Ivan Godfellow on 2014 he actually developed that generative adversarial network, that is the GAN, which pit two neural network against each other to generate increasingly realistic content. And this generative adversarial network GAN actually revolutionized this generative part. And there are a lot of development happen. And as we know, from 2022 onwards, ChatGPT actually revolutionizes these NLP systems, but it also has timeline and path. I will highly ask my audience to look more into generative AI revolution due to time shortage. I am just give you a brief overview. So, what are the foundations of AI? What are the associated field to learn AI? what should the audience should focus on, the students should focus on, what are the technology they should learn to be master in AI. First of all, we need motivation, why you should know AI. So I will go with a quote of Andrew Ng. He's the co-founder of Coursera and also the Stanford Computer Science adjunct faculty from head of Baidu AI Group and the Google Brain as well. So Coursera, anyone may be familiar with. It is the there are many other online learning platforms, but this is actually the um, very vast and well diversified knowledge and information courses. You can learn from Coursera, and many courses are free. So you can learn freely without paying a single penny, single rupees to anyone, just having an internet connection. So he says AI is the new electricity. So this new electricity signifies that the potential within AI system is as enormous as the revolution of electricity. So think about your life without electricity, and nowadays it's very similar. Think about your life without AI, like that. So what are the associated field of AI? So I mentioned machine learning, neural network, deep learning, representation learning, and XAI, that is explainable artificial intelligence. And there is a new field emerging rapidly called reinforcement learning, where we says we do not give much emphasis on previous data. We do not need data to understand new things, to understand how to make decision on current systems. Without previous learning, we can make intelligent decision. That is a very different kind of things, and we call it reinforcement learning. I will highly encourage to my audience to check out this book written by Stuart J. Russell, Stuart Johnson's Artificial Intelligence, a Modern Approach, um, Upper Liver, ANJ, and Princess Hall publications. So what is this? Machine learning. So machine learning is the field of study that gives computer the ability to learn without being explicitly programmed. So what is explicitly programmed? So try to understand by a simple example. Suppose we write a code in our programming language to multiply numbers or to add numbers, do very simple mathematical operations. So when we write a program to add two numbers, we implicitly define variable, we implicitly define equation, we implicitly define where the value need to be stored and then print those values. So this is called each and every instruction we actually guide it. So machine learning is such a thing, they can learn how to make use of those equation and take decision accordingly. That is called explicit programmed. Basically, that is actually the central part. Machine learning guide us to make decisions. So can machine learning can code? Yes. Automated system can code and take decisions. Even you can simply get an overview when you ask anything on ChatGPT, they can generate code, but that code has some flaws still now. But it is actually revolutionized because they come up with a code which is most of the time you can refine and make much sophisticated and runnable code. So what are the domain of this learning? What is learning basically? So learning basically how we interpret data to our system. So suppose I give you a very small example. Think about these systems and these systems as a model in it. So this model is a computer. That model we can write as a statistical model or a model fit up with neural networks and other things. And that model actually learn different hyperparameters and parameters. And we actually feed different data. From those data, they generate some robust features. What is robust feature? Feature which are unique, which cannot be changed over different transforming procedures. And again and again, when we are doing this, the model can learn, and after learning, they can take decisions. So I also showing you this very easily follow regression model where we try to plot different points or data points in a single line, and we call it, this is a regression line, y equal to mx plus c, this basic simple line by which how we can find the best fit line for a system. That is our goal. So when we are able to find that best fit line, that is actually the prediction, this part. And so a lot of input we need to feed with our function. This function actually our model. It could be a lot of repetitive procedures, back propagations and others. When you are learning neural net, you will get to know about those. And nowadays, we are using more sophisticated activation function by which data actually learn, and then we generate those prediction model. Try to understand another thing in this part, that how we represent data. I will discuss more in data science part. That actually also a big part in any kind of a representation. Suppose when you feed data like images, how those images seen by the computer system, rather our digital machine. That is also a huge part of understanding AI system, making AI system more perfect. So all these learning model, actually, I mentioned they are actually divided into different part. One is called supervised model. Another is called semi-supervised model. Another one is unsupervised model, and another one is reinforcement learning. So what is a supervised model? Supervised model is a model by which data can be, model can learn from the data and take decision on the basis of those learned things. So it is fully guided things, like when a teacher is actually teaching in a class. So the teacher actually uh, deliver the lecture to make their students understand everything on their uh, way. So whenever a teacher actually explains something in their way, the student learn accordingly to that. But it is, though it is holistic, because a student, when they perceive that, they also in their neural processing in their brain, they are actually accumulate those data differently. That's why many students, though taking the same class, perform differently. Their outcome is different because they are processing by their own as well. But it is actually the simplest example of supervised model. So what is semi-supervised model? Where some sort of data is known and some sort of decision making can be happen within a particular system by its own. So it's a mix of supervised and unsupervised. That is actually semi-supervised, we call it. And what is unsupervised model? Unsupervised model signify that the data that we feed will not provide any label. So what is label of a data? Label of a data, I'll give you a very small example. So I think about a particular model which actually need to predict whether he sees cats or dogs. So what do we do? Initially, we fed a lot of cats images and a lot of dogs images. So when we say in supervised learning that these are cats images, so the machine already know their label is already defined as a cats. And when we fed in that model dogs images, we already named that label as a dog, and machine understand these are dogs images. So what is the part from machine neural network? What they need to learn? They need to learn the different patterns, different underlying features with those cats and dogs images. So that is actually the supervised part. So when we're talking about unsupervised part, that time we feed only those images. We do not label cats and dogs, and we feed different images, and we ask the model try to distinguish those images. So how they categorize, how they cluster those different portions of the data, and how many clusters they generate. Obviously, if we only fed cats and dogs images, it will cluster in two categories. And depending upon that, they are understanding different categories, different class of a data of data that is actually unsupervised one. And a new learning that we discuss, reinforcement learning, what it actually works. It works in a different way. Here, we actually make two kind of a concept. One is called exploitation, and another one is called exploration. So this exploration phase where they do not have any prior knowledge. So no data actually need to be fed on the system. They're just exploring the new environment and understanding by making a lot of decisions. And it is mostly used in game playing, robot design, like realistic robot systems. And nowadays it is actually used in many other systems as well. But initially the uh, concept was generating to play games, automatic computer games, where a lot of exploration needed to be performed by the agents, software agents. So those software agents, they explore and they learn things, and when they learn things, they now create those knowledge bases. So those knowledge bases actually created by the agent itself by exploring, and while gathering those knowledge bases, they are refining their decision making. So this is actually reinforcement learning, and when they're refining those decision making, we call it uh, exploitation of their exploration information. Their knowledge base, they are exploiting to gain the base decision from the knowledge base. So in a very simplistic way to understand this different model, this is which is the fastest process, that is the supervised one. Semi-supervised, computer need to perform a lot of activities to understand data. That's why it's a little bit slow. Unsupervised is slow in terms of understanding, and reinforcement learning taking more time to process data. But this is actually fixed. Every slow and fast is actually relevant and relative on what kind of machine we are using. So if we can have a very sophisticated machine, then reinforcement learning can be fast. If we have very sophisticated machine, and that decision can be very sophisticated one and very applicable compared to others. So these all kind of a learning actually applied to different AI systems and have very much interconnectivity within it. So what are the application field that we can think of in this machine learning paradigm? So there would be a meaningful application like big data visualization. Big data is nowadays also popular field. Image classification, customer retention, diagnostics of different medical systems, like diagnosis of whether a particular disease is exist or not on different data sets. It could be image data set, lot of like image like X-ray, CT scans, and other diagnostics tools actually design and computationally just having the particular data or particular image, they can diagnose those things. Um, advertising popularity predictions, that is actually a kind of a thing. A lot of fintech technology also designed for market for forecasting, how the financial world actually work, what are the prediction model that could be generated, weather forecasting is another part, estimating life expectancy, game AI, skill acquisition, learning tasks, robot navigation, real-time decision making. These are the very diversified, and there is no such field exists where we do not use machine learning at all in nowadays applications, even for like a bank who actually giving a loan or giving a credit card, they also do a lot of AI processing, machine learning processing. What is the credit score? How much trustworthy the customer is? That is also come up from the machine learning. So a lot of applications fields are there. Uh, so I will like to discuss about the data science part as well. So what is data science? It is different with the machine learning or AI. So that part I will focus now. So what is data science? Try to understand. So data science, IBM says data science combine math and statistics. So mathematics and statistics, if we combine those models, specialized programming, advanced analytics, artificial intelligence, and machine learning with specific subject matter expertise to uncover actionable insight hidden in a organizational data. So try to understand with these definitions that we are mostly concerned when we are talking about data science, concerned about understanding the data, understanding the underlying meaning of a data, and a application area, mostly organizational data. It could be educational organization, it could be a corporate understanding, any industry, stuff like that. And while having those insight, uh, which can be used to guide decision making and strategic planning. So this is actually the central part of any kind of data science field. So we should focus on understanding the data in a different way, using different technologies. And the application part is to guide the decision making and strategic planning. So what's the difference? I know my audience already understand some part of it, what is the difference lies, but it is actually integrating with lot of technologies, and it is, you can call it, some people like to call it, it's a part of AI, but the central focus is to have some application areas and mostly solve industrial problem, organizational problem, and guide them to make proper decisions. So data science studies data and how to extract meaning from it, whereas machine learning is the field devoted to understanding and building methods that utilize data to improve performance and inform predictions. So when we are talking about machine learning, our focus is not where it can be applied, but our focus is more general, how to refine those methodology, the technological innovations appropriately, so that a proper machine learning model can be produce. But when you are talking about data science, we are more focused on how that data can be used in a organizational decision making and plan. So machine learning is a branch of artificial intelligence. Now, how we call it data science? Can we make it a branch of AI? So it is a, as I mentioned, it is a subfield of AI, you can say. And here, the goal is little bit different than the machine learning. So in every data science application or model, whenever you design, you need machine learning to make those systems. And but there is some specific, and when we call it specific, it actually focuses on a very particular goals. So data can fool you. Is there any possibility that data can mislead you, and how they mislead you? So we will give you some very simple understanding on that, because data may not sufficient enough to tell the actual truth. Truth may be misinterpreted by showing a wrong data. That is also possible. So whatever data science model that we develop, that may not reflect the actual truth maybe. So what are the loophole exist in data? So data that have been presented in a way that actually twist the truth, and twisting means in any sort of ways by which it is actually shown to you that this is actually reflecting this, but we are actually avoiding so many underlying things that is not actually the actual truth. It hides the actual truth or mislead you, create an incorrect impression on that. So they can arise from error in data collections. When we actually collect those data, uh, there could be a lot of problems happens, and when we collect those data and interpret those data, there are a lot of variations actually happen, a lot of transformation actually happen. And when you see data on a digital platform or understanding data without digital platform or just human perceptions, how the data collected, that matters. How we analyze those data, that matters. How we interpret those data, that matters. They can be result of intentional manipulations. Who will intentionally do that? So suppose if you ask the computer system, suppose Google something or use any search engine to search about anything. Suppose how good a particular fruit is or how good a particular thing is. So when you focus on good, whatever search result you will got, that mostly focus on good things about that particular topic. Just change your search topic and says how bad that thing is. So when you search on how bad that particular topic or that particular food or that particular item is, the search engine, they generate those data coming up those search engine website where you will find the emphasizes on how bad that particular things is. So these two are contradictory to each other. This is a very simplistic example. There are a lot of variety of different applications where data can be twisted, data can be misinterpreted. So there are some terms we also use in this regard. What are those terms? There is a cherry picking data. So this involves selecting specific data point that support a desired conclusion while disregarding data that may contradict it. It's like telling only part of the story to make a point seem stronger than it is. So we emphasizing and making our audience focuses on a particular domain and avoiding other parts. So it call it cherry picking data. Overgeneralization in terms of system model generation, you may aware of the overfitting and underfitting by size of the data. And if we make more data to the system, the training data sets is more, and they mostly focus on overfitting, then that is actually an imperfect model. Also underfitting, low amount of data can also be used to generate a system, and that system cannot produce value. Any deep learning, machine learning model need huge amount of data. Without huge amount of data, but if there is a oversize sample, that can have problem, as well as undersize, underfitting also have a problem. More specifically, we call it bias sampling. Bias sampling means you fed a lot of data. So suppose I give you a very small example. Suppose a computer system, a model need to predict whether whatever image he sees, whether it is cats and dogs. So you fed data, and in data we call it, when you are actually designing a machine learning or a AI model, there are different names of those data. We call it train data, validation data, and test data. So trained data set should be comprises of all possible combinations of the data. And if we say we are training computer system, only cats and dogs, all possible variety of cats and dogs to be fitted. And it is not 100% feasible because all possible images of cats and dogs we cannot fit. We need a uh, like a specific numbers to fit our system. Another thing you need to understand, whatever value you are fitting on your digital system, that is actually is not an infinite system. In mathematical theories, we can generate theories that can beyond our restricted system. Our system is a finite machines. And finite machines learn data, especially our digital computer system, learn data in terms of a values, mostly numerical values. The way we actually um, coded those information in terms of different numerical values. That's why we need different mathematics and statistical interpolation to understand data. But that transformations of numerical values of the general data have some biasness within that. And if we do not have uniformity in the trained data, validation data, and test data, if we do not have all possible combination of those data samples, that is actually a bias sampling. And it is actually can mislead you. Those system, those model can mislead you and cannot give you the actual truth or actual prediction. That's why many machine learning systems they are actually failed when you apply it for general intelligence or making real life systems, and a lot of new innovations we need to do in that regard. So therefore, the things come as what are the shortcomings of AI. So I will highly encourage my audience to read a paper where from this actually a very interesting story come into exist. That is New and A, Johnson G, and Cause D. They propose a something called XAI, where from XAI actually evolved. Their paper name is Deep Neural Network are easily fooled, high confidence predictions for unrecognizable images. This is actually openly available at CBPR 15. If you look into computer vision and pattern recognition 2005 15 papers, you will find this paper freely available, and where you can look into how they actually make a system that fool the deep learning model. So when they are actually this model, I'll give you a very short overview of this. So when actually we misinterpret our data and feed wrong data to our system, the system is human design, though it has artificial intelligence, but it, as I mentioned, they need to learn from some data. What if we actually change the data? Then machine will learn not the actual thing, but the different things which is not feasible for practical applications. So suppose we have we need to make a model that can predict guitar and penguin. We fed a lot of data on this regard, and the machine come up with a model that has 98.90 accuracy of detecting guitar perfectly on test images, and 99.99% perfection on penguin image detections. But what if we actually put some data as guitar and penguin, then they predict these images as the test images, which actually having match of patterns with the guitar. As we see, this is 99.99% accuracy, but this is not guitar, and this is not penguin. So what happened? So the happening thing is like that. They call it evolutionary algorithm, where we can detect the fault and refine that. But what happens if we just put the data incorrectly? The machine can be fooled. So suppose that article was also very famous, like when like automated car was actually coming into existence, that time there are different sign board in the US, and someone actually manually misinterpreted some signboard by just by covering those signboard, and their automated systems actually fail to recognize that. Suppose a speed limit of 45 miles per hour change, they can change certain value or disregard the value, the system can learn negative thing. That's why what happened in the US currently, like many roads in the US, there are many signboard which need to be performed according to their position of schools and others. And when the school is on, the speed limit is different, and when the school is off, the speed limit is different. Also, in different hilly regions and other regions where you have another kind of a speed limit that is not the actual speed limit. So to get perfectly understand those speed limit, you need to have some sort of more intelligence, and our automated system actually failed in most of the cases. That's why it is still not used in certain regions, but certain regions you can have a Uber-like or other kind of a car that can come and fully without driver, they can drive you in certain portions. But there are a lot of loophole exist within our AI system. That's why it cannot be applied in all areas. So that is actually the central part of explainable AI, where we need to learn new technology to um, make a system that can give you insight into those AI system. Most of the time, whatever AI model we generate, we call it black box model. Black box means they know what to produce, what to do, but they are not give you actual overview of what inside that particular black box. So that will be revealed by this kind of a new kind of AI called explainable AI. The objective is making the black box is explainable to you, so that human can make more appropriate use of those systems and can make more um, feasible, practically applicable AI systems. So there are some try already made and a lot of new systems already generated. I will just discuss few models in this regard. And I will highly encourage my audience to look beyond those models, search about those things. And I already shared my slides, so you can have my slide and look into those more. One thing is local interpretable model, agnostics explanation, that is line model. It is a post hoc model based on false promises. And another one is reverse time attention retain model that is actually developed by Georgia Tech, very renowned US institute for prediction of heart failure. And another one is layer-wise relevance propagations, LRP, which finds most relevant input values in neural net. So these are all um, different models you can look into. Due to time shortage, I just name those, but you can look into more on that. Now I will discuss about that ethical aspect, which is actually different sort of regulations and rules actually provided. So to give you an insight what is ethical part is, so ethics is knowing the difference between what you have a right to do and what is right to do. So the what you have a right to do, that is the legal part. Legally, you are allowed to develop this kind of systems. An ethical part, what is right to do, though it is not under the any legal framework, but ethically as a human, we need to think whether we need to develop this system or not. And I will highly encourage going to the USS White House blueprint for an AI Bill of Right. Already they proposed this. And in European Union, they also have similar kind of bills on that. And this is the source where from you go through and look into that. The basic aspect of any ethical systems whether it is applied in Industry 6.0, AI, data science, and others, we need to focus on this legal part first. And this legal part is actually changing. There are different cyber law does not exist before, now we are existing. There are different AI law that do not exist before, now we are existing. And we need to constantly looking into how much this ethical part can be included in this legal part. So our goal in this ethical aspect is to making this circle bigger, so that anything that is unethical, that is unhuman, uh, that should have a legal framework, and we can protect those systems for the betterment of our society and the betterment for our civilizations. So thank you everyone for listening to my talk. And if you have any questions, please let me know as well. If anyone has any question, they can ask me.
Please feel free to ask questions. Dear participants, if you have any question, please feel free to ask. You may either unmute your microphone or write your questions in the chat box. Okay, we have got a question from Mr. Shoham Dash. How to implement in law enforcement sector? I guess the question is like how to implement AI in law enforcement sector.
Yes. So AI is already in the scanner, and different laws already proposes. European Union was fast. They come up with different laws. Like nowadays, when you are searching anything on the Google or any web search engine, you see like they are now asking your cookies, what kind of cookies you like to store on your system. Cookies means whatever the data that you are sharing. Whether you are sharing your IP, sharing your personal details, stuff like that. So already it is implemented, but we need much more because it is not a fixed process, it's a dynamic and a constantly changing process. So a lot of, as I mentioned in my last slide, our goal is to make that circle bigger and bigger, so that all kind of ethical aspect we can integrate it with our legal framework. I hope I answer your questions. If you need more clarity, please let me know.
Okay, I guess Mr. Shoham, you have got your answer. In case you need more clarification, you can contact our speaker, Dr. Somenath Chakraborty, through his mail ID. And I guess we don't have any more question here. A lot of people appreciating this. Okay, we have got another question. Okay, not another question. Shoham Das has edited his question only, but no question as such. Okay, this is for the participants. We have already shared the attendance link, attendance come feedback link with you, which will remain open. This chat will remain open till 5:40, and this Google form is going to accept a response till 8 o'clock today. Okay, so thank you so much, Dr. Chakraborty, for this wonderful talk. This has been really a fascinating one. You have discussed you have given an overview of AI and data science and have explained things in very simpler terms. Uh, in a nutshell, you have also talked about the ethical aspects as well. So absolutely following the title of this FDP, you have discussed the areas and all the possible avenues in such a short period of time. Despite time constraints, you have made it possible. Thank you so much for that. The chronological evolution of AI and data science. Thank you for this wonderful talk, and also thank you all the participants for being so patient, hearing this discussion and taking part in this entire process. Tomorrow again we come up with another session in the second half. Hope you all join that session. That would also be a very engaging one, as well as it's going to be really another learning experience. Once again, thank you, Dr. Chakraborty, on behalf of Hooghly Engineering and Technology College. And that brings us to the end of Day 3 FDP, organized by IQAC, IIC, and EDC of Hooghly Engineering and Technology College. This is Dr. Shubham Ganguly from Basic Science and Humanities Department, signing off. Thank you.
Thank you, and thank you for having me.
Yeah, okay.
Bye-bye, everyone.
Bye-bye.